lot of the UNC math competition stuff, so I'm doing 60 Google Forms. All right, but I'll have them done Monday. Questions on any four? 25. 25 on 94. 25 on 94. Okay, 25 and 94. 2x squared, it's not replaced, is it? No. All right. F plus x equals 2x cubed minus x squared plus 3 over 2 minus x. That's kind of gross. So this could actually be a bit of a mess. Describe the zeros. Vertical asymptotes and end behavior. Golly. So first of all, do you agree that if x equals 2 is a 0 at the top, then it's a hole? But if x equals 2 is not a 0 at the top, then we're talking vertical asymptote, yeah? So the first thing I guess I would do is say, is 2 a 0 to this? And I'm feeling like 16 minus 4 is no. So x equals 2 is a vertical asymptote. The zeros amount to solving the cube. That kind of stinks. Does it synthetically divide nicely? Oh, 2, 3, 1. Oh, it feels like, nope, I was feeling like the roots were obvious, but I don't see it. Am I missing something? So, 0, obviously it's not it. 1, how about 1? 2 minus, that's ridiculous. 2 minus 1 plus 3 is a no. 3 is a possibility? It's so deathly quiet in here. That's not working. 15, 45, so 3 is a no. What about 3 halves is a possibility? Am I doing this right? Or that's why you're asking about it, because you weren't sure the zeros here. Let's go negative 1. How's that sound? 2, negative 1, 0, 3. 2, negative 2. I'm feeling negative 3, 3, 3, negative 3. Boom, goes the dynamite. Okay, so x plus 1, bingo. 1, 0 is negative 1. 2x squared minus 3x plus 3 over 2 minus x. What about that? Does that have, it doesn't factor 2x squared minus 3x plus 3, I don't think. So does it have real zeros? Negative. So 3 plus or minus 9 minus 4, 2. So I'm feeling negative roots there, so imaginary solutions. Are you down? Okay, so there's only one real root, which every cube must have. Cool. All right, so I'm getting it. X equals 2 is a vertical asymptote. X equals negative 1 is a 0. What else did I ask about? End behavior. The end behavior. End behavior is as the limit as x goes to infinity, y goes to, so it's feeling like 2x cubed over negative x. Feels like negative x squared-y. So end behavior is negative infinity and negative infinity on both sides. That's following a negative parabola curve shape. You follow? So the end behavior is like that. And then we sketch. So 2 is a vertical asymptote. Negative 1 is a 0. I guess like if I really wanted to do a super duper job, which I don't, I could divide, get the parabolic asymptote, put it in standard form to see where the vertex is and actually locate it perfectly. But I'm not that invested in it, so I'm just going to go parabolic of some sort, and then stuff. So I'm feeling like it would go here, and then like that, and if it has no zeros here, and it's going to fall there, it's got to do some kind of that-y behavior. I think that would be the graph. How high? I guess I could take the derivative and find the max, but I won't do that either. All right. Are we good on, did I do everything there? The domain and range. Oh, sorry, the domain. Is there any x that cannot be used? X cannot be 2. And the range. This obviously has a restriction, but this guy's going forever, so I'm feeling all right for that. Okay? Anything else on 94? All right, 95. Here we go. Questions on 95? Yeah, 1. So, 1. All right. So 1. You sure about 1? Well, here's the deal. 1 is going to take me about half of a page. And because you asked about it, I expect it to be correct on your homework. And so if it's not complete on your homework, I would definitely take off a point. And so here we go. I guess I'll tell you that I feel like, I debate whether to put this on, and I feel like it's value added, it's worth giving you, because although it'll take 15 minutes to do, and I'm probably underestimating that, it's a measure of grit. It'll teach you grit. Hey, you're here.
I am here.
How'd you do?
I did okay.
Oh,
I've been sick.
yeah, I was going to
so-
say, that makes it hard to do things. Okay, by the way, back. So, you need to take a test, probably Monday. Okay. All right, so 95-1, it's going to be rough, but it cleans up eventually, and so just persevere, all right? Like this. So I need part A first. They want a cone that, given that the volume has to be 100, find the dimensions that would give you the minimum possible lateral surface area. Height is the overarching question. Part A then is to get a lateral surface area equation in terms of R. Now we know lateral surface area is pi r L. So I started by saying, well, let me look for another relationship, and that other relationship is by Pythagorean theorem. And so I said, well, I know that r squared plus h squared equals L squared, and that's super duper, but that's also 3 variables. And so I need another relationship, and that is the volume. Volume is 100, and that's 1/3 pi r squared h, and so h is 300 over pi r squared. Now, if I use that, then I get r squared plus 300 over pi r squared equals L squared. So L is the square root of that. Therefore, the lateral surface area is pi r root r squared plus 300 over pi r squared, all squared. And that's part A. And that's the easy part. It's pretty gross. It's pretty ugly. And because part B asks you to now find the minimum surface area, I need to take on derivative on that. So I feel like that would be much better done if I cleaned it up. Would I want to clean it up? I feel like I do want to clean it up. All right. So before I take that derivative, here goes with some cleanup. Check this out. I could say that 300 squared is 9 with 1, 2, 3, 4 zeros. And pi r squared is pi squared r to the 4th. I could then get a common denominator and get pi squared r to the 6th plus 90,000 over pi squared r to the 4th. If I then break that root into 2 separate, the top is pi squared r to the 6th plus 90,000, and and the denominator is pi r to the second. Pi divides away, and an r divides away. So lateral surface area in a fairly clean form, pi squared r to the sixth plus 90,000 r to the negative 1. Now that's a testament right there to how ugly this problem is, because if I feel like that's a clean form, then what's an ugly form? So now let's talk L prime, shall we? Byproduct rule. First stays the same. Derivative of the second is negative 1 over r squared, plus second stays the same, times the derivative of the first. Derivative of the first. So the derivative of the outer function, the square root function, would be 2, drop it to a negative half, which means that root ends up in the denominator. And then I do by chain rule derivative of the inside. Derivative of the inside would be something like 6 pi squared r to the fifth. Right? All right. Now I need to find the critical numbers. So what I define. If I were to get a common denominator, let's call the common denominator. You want to hack that 2 off? Let's hack that 2 off. What do you say? Are we done? Okay. So the common denominator is r squared root I squared r to the 6 plus 90,000. This guy, you had the r squared, you multiplied it by the root. And so it's negative pi squared r to the 6 plus 90,000. Wait. This guy, you had an r, so you need another r. And so it's going to be 3 pi squared r to the 6th. Cool? Cool. 0 round. Let's finish it out by simplifying the numerator. I'm getting 2 pi squared r to the 6th minus 90,000. That's pretty clean. R squared pi squared r to the 6th plus 90,000. Now, L prime is undefined if r is 0, which that's silly. That cone cannot have a 0 diameter. That's not in the domain, or 0 radius, so that's out. That can't be 0 because even power plus 90,000, it just can never be 0. It's positive only. And so my only issue is 2 pi squared r to the 6th, L prime is equal to 0, if the numerator equals 0. 2 pi squared r to the 6th minus 90,000 equals 0, which would mean that r is 45,000 over pi squared 6th rooted. So the 6th root of about 5,000. Could be 3 or 4. So. Okay. I think now do I have to? For a small r, this would come out negative. For a big R, this would come out positive. So it does feel like L prime is negative to positive there. That is a min achieved, and I don't know now if I answered the question. It did say find the R or find the surface area. Please tell me it just says find the R.
On the R and the H.
All right. Well, that's the R. The H then is 300 over something. Pi times that bad boy squared. Now, if you think that sucks. Having to copy it from me, put yourself in my shoes. First of all, that's the second time it's coming today. Also, if I make one mistake, then am I supposed to do it if you can't do it? Okay, then just so, you know what, it's not so bad for you, all right? That's it. Phew. Feels like we should just call it a day after that one, but we still have 20 minutes. So here we go. Other questions on 95? 6. Boom. Okay. 6. That was an exercise in perseverance there. Also, boy, 8 or 5 was a humdinger also. 6. Let's go 6. 6, 0 to 1 to 4. All right, so I assume that the first part, finding it exactly, was fine, yeah? The maximum possible, oh, no, sorry, A was the trapezoid estimate. Oh, you good?
Yeah.
Okay, cool. Okay. What else do you have? Do you want 5? Do you need to talk about 5? Or no?
What's the answer for 12?
12. I did not do it, but I imagine it was something like you used pi over 6, pi over 4, pi over 3 before you got to pi over 2. So my first trap would be pi over 6 as a divided by 2 and 0 plus 1/2. Plus, that's pi over 12y over 2, and that's 1/2 plus root 2 over 2, plus pi over 12 over 2, and that's root 2 over 2 plus root 3 over 2, plus pi over 6, root 3 over 2 plus 1. That's my answer. Is that what you got? Cool. All right. All right. What else? Okay. I gotta say, I thought, I made 5 200. I don't know if that was really good. Maybe not. Okay. Well, let me know what I can do to help you.
5.
Okay. All righty then. Boom. 5. So, you are given a velocity function. V equals 8 pi cosine 4 pi t plus pi over 2. And you're to find the total distance in the positive direction. Total distance in the positive direction. So I assume in part A you find the at-rest points by finding where cosine is 0, and that would be when the angle turns out to be pi over 2, or 3 pi over 2, or 5 pi over 2, or 7 pi over 2, etc. That means 4 pi t would have to be 0, or pi, or 2 pi, or 3 pi. So t is 0, or 1/4, or 2/4, or 3/4, or 1, so on. All right, boom. Now, part B says distance in the positive direction. So I need to first find when is V positive. You can imagine the graph of the V function if you like. I just thought 1/8 in the first interval. If I go 1/8, 4 pi over 8 is pi over 2. Pi over 2 plus pi over 2 is pi. Cosine of pi is negative. 1/4 to 2/4, I think it'll alternate signs. I'll do one more just to verify. So I did 3/8. 4 pi over t times, 4 pi times 3/8 is 3 pi over 2. 3 pi over 2 plus pi over 2 is 2 pi. Cosine of 2 pi is positive. So I'm feeling it's positive in those intervals. Now, I also, thankfully, they gave you 2 full intervals. And so rather than do each, I just said double because of the symmetry here. So I said 2 times the integral from 1/4 to 1/2 of the velocity function, going with symmetry. Cool? And I didn't need to negate it because in this case I talked about the positive direction, so it's positive. It's real cool. All right, now integrating this. I didn't use sub this, I mentally used sub this, so in my mind I kind of thought, well, my u would be 4 pi t plus pi over 2, so my du is 4 pi dt. Now I kind of have that. I feel like I have 4 pi there if I broke that up and called it 4 times that. Then in my mind it would be 4 cosine u du. You follow? If I made that substitution. All right. Now, by doing that mentally, then I have to change the limits and all that stuff. You could do this and actually use some of it. That's fine. I just am in the habit of trying to do it a little more mentally. So the antiderivative of cosine u is negative sine u or sine u? Sine u. So sine u, but sine up 4 pi t plus pi over 2 from 1/4 to 1/2. That's 4 times sine of, let's see, 4 pi over 2, which is 2 pi. Sine of 2 pi plus pi over 2 is sine of like 5 pi over 2. 5 pi over 2 is like pi over 2. So that, I imagine, would be 1 minus sine of 1/4. So that'd be pi over 2 plus, sorry, pi plus pi over 2, that's like 3 pi over 2. So I'm getting something like 4 times 1 minus negative 1. And I go with 8. Cool? I hope that's right. If it's not right, don't show me. All right. Actually, I would like to. Any other questions on 95? 14. Okie dokie. 14. 14's got a great technique that you would want in your toolkit as a high-level math student. There's a certain, think of it like U-sub. It's actually thought of as a U-sub technique. So 14, go with this. The limit as x goes to infinity of x sine of 1 over x. So wouldn't you say that the limit as x goes to infinity of x is infinity, and the limit as x goes to infinity of sine of 1 over x is sine of 0, which is 0, so it is in a determinate form, yeah? So the question is, what to do, what to do? Well, this is what I suggest you do. You let u equal 1 over x. Now, if you do that, then x must be 1 over u. Now, that then changes the problem to more like, instead of x, I have 1 over u, and instead of sine of 1 over x, I have sine of u. Cool? Now, the limit has to change also, kind of like a limits of integration problem. If x goes to infinity, what would u go to? 0. So this is equivalent to that. And that's easy. In fact, we know that. We've done that a million times. What do we know that limit to be? 1. So that's a nice little technique. If you get oscillating behavior, you might consider a use of. Okay. Glad you're asked. All right. Anything else on 95? 3? Okay. Yeah, 3, they asked about that in the last question. Okay, so 3. Did you do okay with A?
Yeah,
When,
I did okay.
okay, so dx dt was given as 4/5, and in A you found that dy dt is 8/5, if I recall. Is that right?
Yeah.
Okay. So given that, then let's talk part B. How does the distance between the origin and the particle change or the rate of change. So if you consider the distance between the origin and the rate of change, it's how that's changing now. It seems like because the particle is moving this way, because dx and dt, dx dt is positive and dy dt is positive, and it feels like that distance is increasing at that instant when it's at 1, 3. But we'll see. All right. So we need, first of all, to come up with an equation for the distance. We can't find the rate of change in the distance between the origin and a point on the curve until we have an equation for distance. So what did you say for your distance between the two? Think of just distance formula, and this is a varying point. And so by distance formula, we're talking x minus 0 squared plus y minus 0 squared. Now in the last class, at least 2 different people said, oh, I didn't use 0, 0, I used 3, 1, 1, 3. That wasn't the question, they just read it. It's how does the distance between the origin and the curve change? And so that's the way it is. That. After that, you could find the derivative with respect to time. The derivative on the outside would be 1 over 2 root x squared plus y squared, cool, times the derivative of the inside with respect to time. So I'm feeling 2x dx dt plus 2y dy dt. You could divide a 2 out if you like. If you factored out a 2 and then divided it out, it'd be good. And at that point, then you have everything you need. You can evaluate it because you know x is 1, y is 3, dx dt is 4/5, and dy dt is 3/5. That's the biggest evaluation part I've ever seen. You with me? Okie dokie. What else we got on 95? Should we go to the extra practice then? Or at least get down the answers so if you need to work on it more this weekend, you can know if you did well. What do you say? Sure, Mr. Rickman, I'm not paying attention anyway. Go for it. All right, here we go. Number 1, we do one in class. Yeah, sorry, number 2. Oh, where's from? She's always.
She's at state.
Oh, was she there yesterday?
No, she there for that day was yesterday.
Oh, gotcha.
It's confusing.
Yeah. I guess that's way too many people to do on one day. All right. So use the trapezoidal rule of 3 subintervals to approximate the value. I have for number 2, 101 over 2. How does that grab you? Okay. Over under estimate, I would need the second derivative. I got that the second derivative was 12x squared, which is always greater than 0 or equal to 0, I suppose, at 0. And therefore, the trapezoids will overestimate because it's concave up. And for the last one, I got the true value. True value was 53 2/5, which is greater than our first estimate of 50.5. Wait a second.
It's the second derivative is negative. It's 20 minus.
Oh, yeah, sorry. So it's negative 24x squared, thank you. So it's negative 24x squared, so it's concave down. So trapezoids will underestimate. And that actually makes sense. So my trapezoid estimate is less. Sorry, that, I guess I should have caught. Cool? Okay. Let's go to 3. Number 3. It says, which of these is which? Right or left If I did left, it would look like this. If I used right, it would look like this. And trapezoids would be there, yeah? So, which is the least of them, the 0.7811? That's the right. And 0.8675, the middle, trapezoids, and the greatest is left. Okay, which row produced each estimate? Justify your answer. I just said, I got those because I know right is less than trapezoid is less than left. So that's how I knew. So that's why left must be this and right must be that. Okay, that's, I don't know quite what to say. B was a fun question. Which two approximations does the true value lie between? And does it lie between right and traps? Obviously it lies between right and left, but I think they want a little narrower window. So what did you say? Yeah, right and traps, between right and traps. Right is a underestimate, trapezoids is the lesser of the two overestimates, and so the smallest window would be between right and trap. Cool? Although left and right would be true. It feels like you wussed out. All right. Number 4, A, no, there's no A. Never mind. I got 79 and a half. Or 159 halves. Okay. 5, 43.745. Yes? No? I don't hear a lot of Simpson and I agree, so that's all I really need. All right. 7. I think we did 6 together in class. I got 80.8 square meters here. All right. This table here, number 1. I have. Does the table? Oh, sorry. Does the same table seem to indicate that F double is positive or negative? Now you don't. F double is the change in F prime, and you don't have actually the derivative, but you can look at the delta F in the table, and the deltas go like 1.6, 1.2, 0.7, 0.4. Those are negative. Yeah, no, wait a second. 0.1, sorry, and then negative 0.4. What do you notice about the change in those changes? Those changes are decreasing. So I said something like the changes in F are decreasing. So we could assume, or that seems to imply that F prime is decreasing, and then F prime is decreasing, its derivative is negative, which implies F double is negative. Okay. Based on your answer, what about the function? Is it between? It's between M and T, but on which side is which? So the function is between. Which one will be less than the true area, and which one will be more? If second derivative is negative, then it's concave down. So trapezoids will be less, and midpoint, though it's kind of, sorry, hard to see, midpoint would be more because the part where it's underestimating of the bend is going to be less than the part where it's overestimating. So you'll get a greater. Okay? Ooh, boy. Oh well. We got through a little. I'll put the key to that online and you can check it. Did I get 94, 95 today? Have a lovely day. Go outside and do something. Hopefully Lane will just take a nap. It's so boring. So life. You're young. Taking up in your 90s, dude. Get outside and live.
And you what?
No. Why would they put so early? I have to work.
I'll give you updates on
Would you? That'd be great. Are you going out there?
Yeah.
Okay, right. Good for you. Good school spirit. See?
What am I supposed to do outside?
Outside, what are you supposed to do outside? That's right there, that sentence I think just shows the construction of all the What am I supposed to do outside? It's beautiful, look at those mountains.
Yeah, I know, I live in the mountains.
So go outside in your mountains.
And do what?
Hike, hike,
I hate hiking.
climb a tree, look at birds. What?
What if the mountains are far away? I live by suburban households. What can I do outside?
You could walk outside. Is there a lake nearby, a river?
No.
Why dream about something when you can have it? I don't understand you people. If you're going I will look at them and yes. Considering sometimes when you
This one has bar. Yeah, this is bar march.
No.
All of these are checked.
I can't even check Moses. I don't think. King dirt. King.
Okay, so you can do the dirt or the outside, which is E10. It's the same thing, right? Okay, so then you take the dirt times the derivative on the outside. Which the derivative is but you do outside and then go in. Yeah. So then you do tangent, which is secant squared, right? Secant squared is 6. And then you multiply it by
Don't simplify. Don't. Push the box. Good book.
Wait.
Waiting.
Did you turn in any of your sets? Is this due today or is it?
No.
Wait, just.
What?
Because you were being on the walk with me. Yep.
What?
calculus?
Yep.
AP or just regular?
AP, for both levels. There's 2 levels of AP, but yeah, I teach them both.
What about pre-calculus now?
I have taught pre-calculus, but I don't teach it this year.